Hello, everyone. This presentation's on value engineering. My name's Kurt Lieblong, and I'm the state value engineer and a member of the production support office and central office. This presentation will give employees the idea if they're a team member on a value engineering study, what's going to happen during that week. And also if you're a project manager that is having a value engineering study done on your project, you'll get an idea on what is happening during that study. So with that, I'd like to start off the presentation by showing a video that was developed by SAVE International, which was formerly known as the Society of American Value Engineers. And this organization is the organization that certifies our facilitators in how to perform value engineering. And the department uses certified facilitators. So with that, I'll show the video.
Value engineering is a process that has been developed to give you best value for a project or a product or a process.
Essentially, it focuses on the concept of functions. So rather than thinking about what things are, we look at what things do.
So instead of looking at the problem as it's presented, which may be an existing building or an existing product, you redefine the problem in terms of functions, an active verb and a measurable noun.
If we can't break something down into those components, we tend to get confused or misled by the technical complexity of things. So if we were to look at, well, what's the function of a multimedia projector, for example? Really, if I were to describe that in a verb and a noun, it's to project image. It just projects an image, that's all it does. But it does so much more. It's full of buttons and all kinds of different components. It's got a fan in it, it's got all kinds of things. And the functions of those things are what we want to focus on. So what those things do rather than what they are. For instance, the function of a fan in a projector is really to project heat. Is that something the customer wants to pay for? They really just want to project the image. So there's all these other secondary functions that go in to support how the basic function's being delivered. And that's where the opportunity is to find ways to deliver the basic functions in a more efficient and effective manner that eliminates or minimizes those supporting functions.
That's the great success. That's why the results can be phenomenal. And it really takes advantages of particular strengths that we have as humans to be creative. And it puts it into a formalized process that always gives us great results.
Value engineering came out of General Electric in the 40s, and it was really a response to the shortage of supplies and materials during the war effort.
There was a new engineer hired, his name was Larry Miles at General Electric, and his boss, Harry Ehrlicher, said to Larry Miles that we had to have a solution for this. And they talked about it and came up with this statement: if I can't get the product, I've got to get the function.
Once he understood the why, what it was going to be used for, he was able to generally identify alternative sources or different types of materials that would provide the same function. And out of that exercise, through necessity, he realized that oftentimes he was able to not only identify adequate substitutes, but also identify substitutes that cost less and actually work better.
It became the basis for what General Electric called value analysis, and then was later renamed by our federal government to the term value engineering. So where do I use value engineering? Really across the board, from one-time projects like transportation or buildings to repetitive projects that are bought by the government, but also products. It's interesting because it's really bringing a team of people together to look at a project, and you get different ideas and a change in perspective. And oftentimes those different ideas are extremely valuable.
The value methodology is just an excellent tool for aligning stakeholders in these large projects in a way that allows us to make decisions and get clarity on what's important and what's not, and focus the decision making based on value rather than other things that aren't important.
And if it's a major project that costs multi-millions of dollars, it makes sense to bring a group of people together and have them look at it professionally and give a professional opinion on it.
SAVE International is the preeminent organization in the world that's focused on value engineering. SAVE establishes standards for practice, it provides educational training, it provides really a forum for practitioners and organizations that engage in value engineering activities to exchange information, to share knowledge, and to find ways to advance the methodology and enhance the profession.
We're all working together here as a team, trying to come up with the best solution for the client. So we're an extension of your organization, and we want to work with you.
The greatest opportunity in having an organization join SAVE International is they will get a chance to see and share experiences with other organizations and to really enhance the effectiveness of their programs at the corporate level or organizational level.
From an organizational standpoint, it is an incredible team building experience. It truly helps your organization grow and become what I would call a learning organization. It builds the high performance team.
All right, the important parts about that video, as was mentioned in by Rob Stewart in that video, is the functions that we're looking at are secondary functions. It's the functions that have the most opportunity, not the basic function that we're talking about, but secondary functions that have opportunity for improvement to them. So the objectives for today, I'll give you some background on the VE process and how it got started. We'll talk about what is VE, why, when, what, and how to VE. Potential roles that you may play as either a team member or project manager. Its VE process's relation to other PM tools such as risk management. And then we'll include some references at the end if you want further information. So background on VE. The VE process, as mentioned in the video, was started in the late 40s. It's actually started earlier than that, but was formally established as a process in 1947. And it was as a result of what was happening with the war in World War II. And that General Electric could not get materials to produce the goods that they normally produce because all the materials, the raw materials, were going to the war effort to produce tanks and ships and other things that were needed for the war. So they developed this process to come up with what other kind of materials could they use to help produce their products. It was developed by the Army in 1954, and SAVE International, as I mentioned before, was started as a Society of American Value Engineers, was formed in 1959. And they are a training organization and a certification organization on a value methodology. The first mention in the highway was in the 1970 Highway Act. It was just mentioned, it was encouraged for state DOTs to use the process to get the most value out of their products. Florida started our program in 1978, so this year it's 40 years old. It first came in as a requirement in 1995 National Highway Systems Act, which was a mandate that required the states to study certain projects. That act was put into effect with the 1970 federal regulation, which is 23 CFR 627. And then that regulation was again, or the law actually was modified with Safety Lieu. In 2012, the federal regulation was updated, but had not gone into effect yet. And then MAP 21 came in and changed the law further. So in 2014, the regulation was updated, and it's the current regulation we're now going under. I'm going to show another video here. This one's by Federal Highway and their interpretation, their take on value engineering. It's about a 5-minute video, and we'll start that now.
Imagine you are back in time and responsible for designing one of the most impressive transportation engineering icons, the Golden Gate Bridge. It is a massive and complex project, and there are teams assigned to various components and deadlines to meet. Each team is working hard to make the design decisions that will eventually be used in construction. Let's examine this project more closely and focus on the decisions and recommendations that the design teams came up with. If you invited an independent team to evaluate those recommendations and suggest ways to improve, you stand a good chance of adding value to the project. For example, the foundations of the Golden Gate Bridge are planted deep underwater in the San Francisco Bay, making them a challenge to construct. They make great candidates for this independent team to review and find better, faster, or cheaper ways to build these massive foundations. This independent team is doing something called value engineering, a process proven to produce huge benefits for projects both large and small. The Federal Aid Highway Program has requirements for value engineering. In this short presentation, we will define what value engineering is and when it is required, explain how it works, and illustrate its benefits. Value engineering has proven to be a sound approach that can reduce project costs, improve project quality, eliminate unnecessary design elements, foster innovation, and improve productivity. Value engineering is a process that can reap hefty benefits for your organization, customers, and stakeholders.
In general, value engineering, or VE for short, is the systematic application of recognized techniques by an independent, multidisciplinary team to identify the function of a product or service, establish a worth for that function, and generate alternatives. We'll go into details to make this easier to understand, so let's start by looking at what the value engineering study process can accomplish. There are several objectives that the value engineering study process focuses on beyond achieving the desired level of quality at the lowest cost. The value engineering study process may also look for ways to reduce construction time or make construction easier to accomplish. This process considers all project objectives, such as safety, operational, and environmental commitments, while trying to reduce total ownership costs. Value engineering recommendations may suggest using innovative technologies that improve the finished quality and should consider long-term or life-cycle costs. The value engineering study process can be broken down into 4 core components. When a value engineering study is required, who makes up a value engineering team, following a procedure called the VE job plan, and reporting recommendations. Let's look at each of these in more detail. A value engineering study is required on any federal aid project under the following circumstances. The project is located on the National Highway System and has an estimated total cost of $50 million or more. The project is considered a bridge project located on the National Highway System with an estimated cost of $40 million or more. The project is considered a major project located on or off the National Highway System with a total cost of $500 million or more. A change in project scope or design after the final design and prior to letting for construction causes the project cost to exceed the $50 million threshold for projects on the National Highway System, $40 million threshold for bridge projects on the National Highway System, or the $500 million major project threshold, or any other project the Federal Highway Administration, FHWA, determines to be appropriate. A value engineering study is not required for projects delivered using the design-build method of construction. The value engineering team is comprised of a multidisciplinary group of individuals who are not directly involved in the planning or design of the project. Someone trained and knowledgeable in value engineering techniques to serve as the facilitator and coordinator. The value engineering team follows a procedure called a value engineering job plan, which has 7 phases. In the information phase, project information is gathered, including project commitments and constraints. The function analysis phase analyzes the project to understand the required functions. In the creative phase, ideas are generated on ways to accomplish the required functions, improve the project's performance, enhance its quality, and lower project costs. The evaluation phase involves evaluating and selecting feasible ideas for development. The development phase takes these selected ideas and turns them into fully supported recommendations. The presentation phase presents the value engineering recommendations to the project stakeholders. And the resolution phase is when these recommendations are evaluated, approved, or denied. These decisions are documented, and all approved recommendations are then implemented. The value engineering study culminates with a formal written report documenting the following: the analysis approach following the value engineering job plan, the proposed recommendations and decisions made. A value engineering study normally takes 3 to 5 days to complete, depending on the project's complexity, followed by a formal report documenting the study team's recommendations. The study should be conducted as early in the design process as possible to maximize potential value engineering recommendations. Being prepared to review and then approve or reject recommendations in a timely manner will help ensure changes to the project can be quickly incorporated into the project design. Once these decisions have been made, maintain a copy of the report for at least 3 years after the project has been closed out.
Whether your federal aid project barely exceeds the monetary threshold for a value engineering study or is as large as the Golden Gate Bridge, the value engineering process can help improve quality and value. Remember, if your agency has a federal aid project and a value engineering study is required, start the process early. Consider the recommendations we've just outlined in this presentation and make sure you comply with all federal regulations.
So more background on the VE, and in that video, they spelled out some requirements. And the current requirements are any project on a national highway system, a federal aid project, that's greater than $50 million needs to have at least one VE study during its development. For bridge project, that requirement is any project over 40 million. Any major project, whether it's on system or off system, has to have a value engineering study done on it. And design build projects are not required. Now, many times we don't know if it's going to design build until we get right before the letting. So really it's due diligence to perform VE studies on those projects. If you know it's definitely going to design build, and many major projects are, it's not a required, by the federal regulation, it's not a required project. And then also any project the FHWA, meaning the division office, determines is appropriate to have a VE study. So even if it doesn't meet any of these requirements that I've listed below or above, and the division office determines that they want a VE study, we will perform a VE study. So just to give you some insight into some statistics, in 1997, the federal regulation was passed. They started collecting data in 1998. So we're about 19 years of data here. And as you can see, Florida is, with Virginia, has conducted the most studies over that 19-year period. And once you get past California, all 3 of those states have more than doubled the rest of the 47 states. In approved cost avoidance, you'll see that Florida again leads with $4.48 billion avoided over that 19-year period. And again, between us, California, and Washington, everything is more than doubled in the 47 other states. So what is value engineering? Well, as pointed out in the FHWA video, value engineering is a systematic application of function-oriented techniques by a multidisciplinary team, and it's to analyze and improve the value of product, process, or service. It's not straight cost reduction. We're not just moving elements or removing elements from a project just to reduce the cost. We're looking at the project and how it functions and seeing whether elements can be eliminated or whether they can be provided in a less expensive manner. So the keys here is it's function oriented and it's a multidisciplinary team. So why use VE? Well, we've got shrinking resources. Ever last, I don't know how many years, we've been going with do more with less. The budget has really gone up, but the amount of projects has gone up. And also, if we control the costs of the projects we put out, then we could potentially put more projects out on the street. It's an opportunity in the study to be bold, innovative, and inspirational. You'll see that, we do creative brainstorming. It's a way that innovative ideas can be introduced into a project. Why use VE? Well, there's an opportunity to improve schedule, possibly constructability. It's a real opportunity if there's stakeholder issues on the project and there's conflict and as a project manager, you can't get resolution to them. Maybe you can have a VE team work on possible ways to resolve those stakeholder issues. And obviously, it's a way to possibly reduce the overall project costs and also operating costs. And the last, which has really grown in popularity in the last several years, it's also a way to mitigate risks. And as I mentioned, I'll be showing you our cost risk analysis program and how we can use the VE process in conjunction with the cost risk analysis program to further better the project. When to apply risk or apply VE. The graph on the screen shows you on the vertical axis the opportunity for change, and the horizontal axis is the project life cycle. So as you can see, earlier in the project, the opportunity to change is much greater. As the project continues to move on, the opportunity for change gets less and less and less. So, VE is a process that's recommending change to a project to improve the project. So when will we apply it? Well, we apply it as early as possible. And usually the last phase that we would apply VE or hold a VE study is around phase 2 or 60% plans. We've held them in planning studies, so the typical information required is really any information that's developed, but a lot of times that information is shown on the screen, aerial photo, any kind of right-of-way, preferred alternative, any traffic information. In a PD&E process, you'll get more refined cost estimates, right-of-way estimates. You'll have probably better traffic analysis by that time. You'll get a summary of public involvement and what kind of commitments are being proposed and we've made. During design, you're getting more refined information, so the plan and profiles probably at a better state. You'll have drainage information and know what type of typical you're using. You'll probably have some cross sections, and your estimate's going to be more refined and closer to where we're trying to get to. Design build projects, as I mentioned, now they're just encouraged through regulation. They're not required, but if they are done, they're conducted prior to the release of the RFP document, or RFP also meaning request for proposal document. And a typical information required is that request for proposal package. And the team will study that and see if there's any improvements that they could recommend that would make it a better document. How is VE done? Well, there's something called the VE job plan. and that includes pre-study steps, what is done, the steps taken during the VE team study, and also some post-study steps, which would include implementation and reporting. So let's look at the pre-study. What projects are selected? And I already talked about some of these, but as the federal highway requires, any project over 50 million or bridge projects over 40 million or federal aid projects on the national highway system, the department requirement is we study any project over 25 million. The difference being that between 25 million and what the federal requirement is, there's a possibility that we can waive requirement if signed off by the Director of Transportation Development. There's no possible way to waive the regulations. So if it's a federal aid project that meet those requirements, it has to be done, no matter what type of project or what's being done, other than the design build project. So our candidates for what's being studied is any project over 25 million. And that doesn't matter on what kind of money it is paid, whether it's federal money, state money, and it doesn't matter on the delivery method, whether it's design build or design bid build. Typically, we do projects that have large right-of-way purchases. Those are typically studied because those costs usually equate more than 25 million and many times more than 50 million. Major bridges, the same. Complex projects. You could have a smaller project that's a little bit complexity to it that may be under 25 million, and we do some of those because the complexity adds to issues that you may be having. Large corridor and multimodal projects we do, and we also get on occasions requests from project manager to conduct a VE study on their project. Who does the study? So team selection. One, we select a team leader. About 90% of our projects are done by consultant team leaders that are professional engineers and are certified through SAVE International as a certified value specialist. We do have some in-house team leaders, and those are employees that have gone through VE training, both team member training and team leader training, and have served on numerous VE studies. We also include design, a member from design, construction, and maintenance. Those are required disciplines that need to be on the team. And then any kind of specialized expert. So if you have right-of-way, a lot of right-of-way on it, we would have a right-of-way member. You have tolls, we would have, typically somebody with tolling experience. Anything that's specialized to the project, we would have that type of expertise on a team. So how is VE done? So we'll move into what's done during this team study in the VE job plan. And during that study, these 5 questions are typically asked. What is it? What does it do? That's what the function is. What does it cost? What else can do it? And what does that cost? Those questions are asked over and over again during the study because you're looking to see different ways to do a function. The information phase. So the team's going to review all the project information. Project information will be distributed to the team typically 1 to 2 weeks prior to the study. Team members are asked to familiarize themselves with the study, any information, and any kind of information related to their specific discipline. The first day of the study is when we're going through this information phase, and as a team, we're going to discuss the design and what the estimate is. And is there things missing? You're going to develop questions for the design team. So the design team is going to come in probably around 10 o'clock, the first day of the study, and they're going to do a presentation on what the project is. So prior to that, the team, the VE team, is going to come up with questions. They're going to review the information, discuss any information that they see that might be missing or need further explanation. And then they're going to come up with questions. And these are typical questions that are asked, what are the constraints? What major issues are you having? What keeps you up at night? What are your significant risks on the project? And then again, they're going to identify any missing information and ask the design team for that information. Then we'll have the team briefing, which is by the design team. They'll come in, they'll do a presentation, they'll explain it. It's an open forum. Everybody asks questions at any time. After the team briefing, typically teams will go on a site visit. Now this has changed with technology. A lot of times you can get enough information off of Google Earth or some other means or method, video logs, and see what the site looks like. It really depends on how far away the site is from where they're meeting and, how much time would be required to do the site visit. But we still do site visits. A lot of teams I've been on has done site visits. The team walks the site as a team, record any observations and take any pictures. One problem that you could have looking at technology, Google Earth, that information could be up to 3 years old. So there could be new businesses that have been constructed along the facility that wouldn't show up on Google Earth. There could be all kinds of things that are out there that you may not be able to pick up off of, say, a Google Earth. Then after the site visit, to come back, do a post-site synopsis. The group shares any observations they had individually. The team will review what the cost model is, and then they'll come up with some broad areas of review of what they think they should be focus on. Cost model. Most of the projects will follow what is called Pareto's rule, which 20% of the functions contain 80% of the costs, and that typically comes out pretty strong. And so one way to do that is that kind of tells the team there's a high cost areas, maybe we should look at these. Doesn't mean they can't look at any of the other areas, and they may, but that can also point them in a direction to see if there's any kind of improvement areas. Function analysis. So this is the phase of value engineering which sets it apart from a lot of other improvement tools. And so what is function? Well, it's the intent or purpose that a product or process or service is expected to perform. And in value engineering, we express that function in two words, an active verb and a measurable noun. So in other words, what does it do would be the active verb, and what does it do it to is the measurable noun. So what is the function of this pencil? Well, many would say the function is to make marks. But there's so many other things that functions to it. The function of the band is to secure the eraser. The function of the eraser is to remove marks. The paint, protects the wood, improves the appearance. The barrel supports the lead, and the graphite ultimately does make the marks. So once we've identified functions, then we go through and classify those functions. And we classify them as basic function, which is a specific purpose for which something exists. So it's a primary purpose and intent. And one thing is, if you can eliminate the basic function, you've eliminated a project. If you don't need to make marks with a pencil, then you don't need the pencil. And then the other thing is the customer must be willing to pay for it. So as mentioned in that save video, Rob Stewart was talking about the multimedia projector, and he said the basic function was to project image. Well, the customer must be willing to pay for projecting an image. And as he mentioned, customer may not be willing to pay for some of the secondary functions. So those are the opportunity areas the VE focuses on to try to improve the project process or a product. Secondary functions support the basic functions. They may or may not add value. They do contribute to the costs, but they may not be essential to the performance of the basic function. During a study, you'll see matrix like this that shows the item, what the function is, the verb and the noun, and then a team will go through together and classify them as whether it's secondary or basic. As you can see, with many of those items that I had on there, they were secondary functions. But the graphite was the basic function, which was make marks. And that is the basic function of that pencil, is to make marks. Another thing that we do during classifying functions is there's two other functions that are called higher order, which is it causes the basic function to exist. So it's the outcome or the result of what the basic function is. And then you have a lower order function, which really is the input to what the project, product, or process is. Maybe it's the raw materials on a product. Another technique that's used along with functional analysis that many of our facilitators will use is called function analysis system technique, also known as fast diagramming. And as you can see from the diagram, there's two scope lines, one to the left, vertical lines, or one to the left, one to the right. The project or the scope of the problem under study is in between those scope lines, and you'll see that the basic function is just to the right of the left scope line. And then what you do is the how and the why. So you should be able to move from box to box, from left to right, asking how does that happen? And the next box will answer that question. And moving right to left, you'll say, why do we do this? And the next box will answer that question. So for example, in the pencil situation, make marks was the basic function. Yeah, we also had remove marks. So you can have functions, if they're in a vertical sense, they're same time functions. But as you move left to right, you say, how do you make marks? Well, you transmit a force. If you move right to left, why do you transmit force to make marks? And you also have secure eraser, support lead on there. And support lead, moving left to right. How do you support the lead? You accommodate the grip. You improve the performance. You protect. Why do you accommodate the grip? To protect the wood. And then moving in the Y direction. Why do you protect the wood? To accommodate grip. Why do you accommodate grip? To support the lead. And ultimately, why do you transmit the force to make the marks? How do you transmit the force? You apply a force. So that's just a simple example of a fast diagram. Fast diagramming is a course in its own. It's not sometimes in complicated projects, it's not an easy concept to get down. But there is information out there on it, and I'll give you references on how to get to that if you're interested. So as I mentioned, basic function was to make marks. All the rest of them are really secondary functions. Record information is your higher order. So why do you make marks or record information? And then the lower order was applied force. So that was function analysis. Now we'll move into a creative phase. So once we've identified functions, we've classified those functions. Now we want to see what kind of ideas, what else can perform those functions? What other ideas do we have that could either improve the function or possibly provide it in a less expensive manner? The most common way of the creative phase is brainstorming technique. So what is brainstorming? It's a technique to get bigger and better ideas. It's a free flow of creative ideas, not bound by any barriers. You want to challenge traditional thinking, and basically you want to ask what else can do the function. As I mentioned, it's a free flow. There's no debating or evaluating ideas once the ideas are presented, or some ideas can build on other ideas. It's to think of new ways to do things. This is where you can be bold, innovative, and come up with new ways to provide the functions. It's always good to be humorous and creative. It's good to have a person on the team that will throw out wild ideas and loosen up the group. And many times by loosening the group up, it can create ideas and get some synergy, ideas that would never be thought of. It's important that everyone participates. And at this point, during creative phase, there are no bad ideas. We'll use the next phase of the process to evaluate the ideas and determine which ones we will move forward. And that leads us into evaluation. So the evaluation phase, the first thing we'll do is we'll go through the list of ideas. Once all the ideas are exhausted, the team facilitator or team leader gets everything out of the team that they can possibly get. Take a break after that and come back, and they'll go through the process of starting to eliminate ideas that were crazy ideas, way out ideas that we know are not going to be considered or be accepted. We'll also go back and say, well, maybe these ideas can work together and it may be combined into a better idea. So we'll eliminate ideas first, we'll combine ideas into maybe a better idea, and then the remaining ideas will be evaluated. And typically these three ways, either weighted matrix is probably the most popular used, the most used. Multi-voting can be used, and team consensus would probably be the second most used. So what is an evaluation matrix? It's a matrix that evaluates ideas against a set criteria. And typically those are weighted criteria. So the first thing you have to do if you use an evaluation matrix is determine what the evaluation criteria are going to be. And the most popular way to weight those is through pair comparison. Each idea that comes up is evaluated against that criteria. And the typical criteria are costs, operations, constructability, maintenance, aesthetics. Those are probably the most popular used. And I've listed those here at the top. Those are criteria. The weightings were weighted through a pair comparison. And so the weight for operations was determined by the team as consensus as a 5, constructability of 4, and so forth and so on. Then the proposed design is evaluated against that criteria. And so they'll have the ratings as far as costs. So it was determined on this one, that was a 4. And then the weight is multiplied by the rating to get an overall score. Then the VE alternative is evaluated along the same way. And then the total score, if the VE alternative comes out higher than the as proposed, then that's probably an idea that's going to move forward and be developed. If it's below, teams still can decide whether they want to move forward, but many times it'll be eliminated. Multi-voting, what is it? Well, it's a decision tool that enables a team to reduce a long list of ideas to a manageable number of ideas. And you can have multiple rounds of multi-voting where, say in the first round, each team member gets 5 votes. The second round, they may get 4 votes and then 3 votes until they get down to a manageable number and the ideas that they want to bring forward. Team consensus is just as it says. It's a group decision, and they decide which ideas to move forward for development. And it is a consensus. Team leader will go around the room, and each team member will say yes or no, or give their thoughts on the idea. And they'll also do it for combining ideas and eliminating ideas. So once the team has decided what ideas to move forward, then they'll move into development. And the first 4, information, function analysis, creativity, evaluation, are typically performed in a 5-day study. They'll finish evaluation usually around noon on a Wednesday if it starts on a Monday. So about 2.5 days. Then development will be the next day and a half, and then the presentation will be on the last day. So as far as development, so the ideas need to be written up into recommendations, descriptions, sketches, calculations, any advantages and disadvantages, and any life cycle costs. And so a life cycle cost is the cost of that idea from concept to the end of its life, cradle to grave. So the descriptions, they need to be clear. Decision makers need to know what's being proposed for the design and what is the VE alternative. Sketches help visualize what the alternative is, what the VE alternative is, and what's being presented. It's just sometimes easier to visualize what is being proposed rather than it in written form. Any calculations that need to support the VE alternative or VE recommendation are included in the write-up. All the advantages and disadvantages. So there's advantages, if we do a VE recommendation, it could be clear advantages to doing that, maybe save costs, maybe improve operations, but then there's some sort of probably disadvantage to doing it. Maybe it takes longer. Maybe it needs, special materials, whatever those disadvantages could be. And then life cycle cost analysis. I'll go a little bit more into this now. So life cycle cost analysis, it is mentioned in the Federal Highway Regulation. It's documentation of stages of the job plan, which would include documentation of life cycle cost analysis that were analyzed. It's not required. It's highly recommended. Life cycle cost analysis is performed, and the life cycle costs are considered. So what is a life cycle cost analysis? Well, it's a tool to determine the most cost-effective operation or option among different competing alternatives. And that includes all the costs, the purchase, to own it, to operate it, maintain it, and even any kind of salvage costs when it's disposed. And the one thing is that all the costs are typically discounted back into net present value, but that only if the life cycles of both alternatives are the same. Otherwise, you'd have to do an annual alternative method, but that's getting into, and life cycle cost can be a course on its own. What I wanted to point out, though, is that life cycle cost is considered within the VE studies and is highly encouraged by Federal Highway Administration. So presentation. So the next phase of the process, and this is when you present the results to management. It's typically done on the last day of the VE study, typically on a Friday, typically a late Friday morning. But it's also, we have had them scheduled separately by the district VE coordinator when they can get all the decision makers available. If the decision makers may not be available on the last day of the study, and they want to make sure that they have the people who need to make decisions on these available for the presentation. There's multiple presenters, so when the ideas are being developed, and typically they'll split into smaller groups to develop the ideas. We'll work in small groups to develop each idea, and not as a whole team, but as individuals may have multiple ones that they need to develop, or it could be working in pairs of 2 or 3 to develop multiple ideas. And so again, they develop those ideas. The presenter is going to be that presents those ideas are going to be chosen from the people that have developed them. So there will be multiple presenters, and because of that, typically on that the late afternoon of Thursday or early on a Friday morning, prior to the presentation, the team will do a dress rehearsal to just to make sure everybody knows who's following who. So it looks a little organized. So that'll be done just prior to the presentation. So now we get down into reporting results, and results are reported on a quarterly basis at the performance meeting to executive management. They're also reported annually to Federal Highway Administration, and as I showed you those charts earlier in the presentation, Federal Highway's been collecting annual results for about 19 years now, and so we report it every year. We get a request from the division and report the numbers back to them. We do develop an annual report that shows statewide results and district results. Here's an example of what's presented at the performance meeting. This was in September of this year. There's an example of Federal Highway, their webpage that shows the summary reports. And this was one that was just released about a week ago for 2017, their fiscal year 2017. And there's a picture of the 2017-18 department annual report that we put out. So VE program results, and I did this over a 10-year period. Now this is results for our particular measures. I showed you, how many studies we've done over that 19-year period and what our cost avoidance savings were over that 19-year period. But in the last 10 years, we've conducted 243 studies, 909 approved recommendations, $2.3 billion in cost avoidance savings. The adoption rate's 53%. Project saved is at 6.78%. And during that same time, we've also approved 240 CSIs, cost savings initiative proposals, which formerly were called value engineering change proposals. And those resulted in, and those are done during construction, and those resulted in about $60 million in savings. So if you're a team member on a study, here's the things that you should be aware of and what's expected of you during that week. So, and not only during the week, but review the pre-study information, fully participate, which means 100% time during that week. You're away from your job for that week. Fully participate during the study. And then after the study, you need to review and comment on the draft report, which will be sent out by the facilitator. just so that what's recorded and how they recorded it is accurate record of what was done during the study. Project manager role, pre-study activities. You need to provide input during project selection. So the district value engineers will put their work plan together. They'll choose studies that ultimately get approved by management. They develop a VE work plan annually, and it has to be submitted to our office by July 1 of each year. So it's important that they'll probably be coming around talking to project managers about their projects if it hits a certain criteria that we're looking at. So it's important to provide input during that when they're putting the work plans together. It's also important for the project manager to provide input during the team selection phase. So if the project's been selected to have a study, provide input on what important disciplines, what are the major issues, so that the VE team, VE coordinator can get the appropriate disciplines on the team, other than just your straight design, construction, and maintenance. If there's specialization, if there's a lot of right away on the project, we need to make sure we have appropriate right away people on the team. And then also to provide all the available information in the project prior to the study, so that we can send it out to the VE team for their review prior to the study. So they're a little bit more familiar with the project than just showing up, green on Monday morning of the study. During the study, project manager, they be available to brief the team the first day of the study, give a presentation on what the project is, what are the main issues, answer any questions that the team may have at that point. It's to be available during the week. That means by phone for any questions that may come up after the briefing, and then to attend the team presentation of the recommendations. Post-study activities is participate in the resolution of the recommendations, provide comments back on the draft report and on any recommendation. And typically, I didn't mention this, but the team typically on Wednesday of the study, the facilitator and the team will want to have what they call a midweek briefing. It's about that noontime on Wednesday. They got their list of ideas that they want to, bring forward and maybe develop, but they like to bounce that off the project team, project manager, see if there's any fatal flaws to them. So it's also to be available for that. Once decisions are made, the project manager needs to inform everyone on the project in writing of all the accepted recommendations so that they can move forward and be developed further. So VE and project management. I'm sure most project managers have heard about the triple constraint. That's quality is equal to scope, time, and costs. It's difficult to balance those, but it's important to balance them to get a quality project. So also there's the project management body of knowledge, and there's 5 project management process groups, and there's 10 knowledge areas. And that PMBOK is also already up to their 6th edition. So those knowledge areas are integration, scope, time, cost, quality, human resources, communications, and risks, procurement, and stakeholder management. And what I wanted to point out in those knowledge areas, there's 7 of them that definitely can assist through the VE process, and the VE can help in those areas. So how they help in those areas? Will improve project schedule. I've showed these areas on how to improve before. It's time, quality, scope, reduce costs, and risk, mitigate risks. So these are areas that of the 10 knowledge areas that the VE process can assist and help improve the project. So I want to give a little bit of overview on the risk management process. Your risk management is a systematic process of identifying, assessing, and responding to risks in order to manage or reduce potential adverse effects on achievement of project goals. And the key here is, the project has a purpose and need. You go through risk identification and assessment. You develop mitigation strategies to respond to those risks, and then you monitor and track, see how that process works. And the important point here is that it's an iterative process. It's not just a one-time thing. It's continuous on a project. So project management, what is risk? Well, PMI defines it as an uncertain event or condition that, if it occurs, can have a negative or positive effect on a project's objectives. Why risk analysis? Improve cost estimates and schedules. Really, it's to validate. We use it to validate the cost and the schedule. And then you can also develop a risk-based contingency. Instead of your traditional contingency that maybe, 15%, 20%, whatever that number is, you actually build your contingency up through risk. And so you're basing it on what you feel are high risk areas. Implement risk mitigation activities. It meets the FHWA financial plan requirements. So projects over 100 million need to have a financial plan. Major projects over 500 million need to have a project management plan, which the financial plan is part of. So it helps meet that requirement of FHWA. And, it maximizes the likelihood of meeting your budget and your project delivery goals, your budget and your schedule. And that's the main reasons we're performing it within the department. So what's a risk analysis workshop like? Well, I described what a VE study is, and typically it's a 5-day study. The risk analysis is really a 2 to 3 day. It's a very structured event. It's to identify and quantify threats and opportunities or risks, and identify possibly maybe some management strategies to mitigate those risks. It's a collaborative team approach. And who participates? Well, the project manager and design team, where, as I said in a VE study, the project manager design team, participate the first day. They're available for questions during the week, and then they come to the presentation. Well, in a risk workshop, they participate the entire risk study. They need to be there 100% of the time the study's going on. And the reason for that is they know the most about the project and what possible risks can come up, and they also know what's been done possibly to mitigate any risks. We also have external subject matter experts and different disciplines. It's all the disciplines that are on part of the project, including maybe possibly some outside agencies, local agencies, and others depending on what the project scope is. So how does this work? Well, the team will identify a risk factor, identify risks. In this case, could be a delay of the NEPA process. They'll determine what's the likelihood of that going to happen. Is it 1 in 3 chance, which in this case, that's what they determine. And then if it does happen, what are the potential impacts? So in this case, it's going to increase the cost by $2 million and it's going to delay the schedule by 12 months. And so during that risk workshop, they'll collect all this information on all the risks that they've identified, and they'll put it into a model, and they'll do some Monte Carlo simulation, and then to determine what the overall effect on the project is. And that's how they can start setting a risk-based contingency and possibly a contingency for the schedule. So this is one of the outputs of a risk assessment. You'll see the vertical lines are the base cost estimate. That's the base cost with any kind of contingency or fluff stripped out of the project. It's if the project was perfect and we could go out and construct it, is what it would be. The next one is a base cost that's escalated through the project. And then the other one is an S-curve, which is your base cost with all your risks identified. And so the most likely cost of the project is going to be at your 50%. That's the height of your bell curve. And then Federal Highway likes to base a contingency on the 70% level. So that would be the difference, and that would be how you would determine what your contingency should be. The risk assessment will also provide a tornado diagram, which identifies what the high risks are. And they'll do it for probably the top 10 risks. So the deliverables out of a risk workshop is a final report that they'll detail the results of the workshop and give you those deliverables I just pointed out. They'll give you the S-curve, the tornado diagram, and they'll also give you a risk register for the project manager to use, which will help them to manage those identified risks. And possibly, as the project moves forward, there'll be some risks that'll fall off. They never happen. Some that were mitigated and reduced the estimate and the schedule delays. And then some that are added that could be potentially new risks. So cost risk analysis and value engineering, this is something that's been popular in the last year or so. And they can be complementary to each other. So you can, use a VE process to develop risk response strategies like mitigation strategies to the risks that were identified in the cost risk analysis workshop. And the CRA can be used on the VE recommendations to evaluate the risks that may be introduced with the VE recommendation and their impact on the cost and schedule. So it's complementary processes. The differences are that during a VE study, the project manager and the design team are only participate at certain points, and during the risk workshop, they participate 100% of the time. So with that, I wanted to show you some references. That concludes the presentation for today. You'll see I've included FDOT's value engineering website, our procedure, also included Federal Highway value engineering website, and Save International website. And so that concludes my presentation. Thank you for being interested in the value engineering process. And if you have any questions, you can contact me at the following information. Thank you.